All right. For this one, sometimes because when you're doing differentiation, one of the most effective ways to differentiate is obviously the use of the chain rule. So the chain rule is very invasive. It can differentiate just about, you can actually use it to go into like inside any function. They'll put a limit, they'll put a limitation sort of and tell you not to use a chain rule. And so this is one example where they might tell you do not use the chain rule. Why? Because if you had this, okay, you can actually change it to that quite fast. Okay, you can change it to this, for example, and then this becomes very easy. Okay, because you know that differentiation of this will use the chain rule, differentiation of that will use the chain rule, the relationship between these two, it will use the quotient rule. So already it's very easy. Now they want you to remember some of the concepts like in trigonometry. So they'll say don't use the chain rule. Okay, so if they give you a concept like that, then obviously, yeah, this one is easier, but sometimes they can be complex. So this one, you're going to try and remember that we said that if you have a squared and then you have b squared, this will be the same as saying a over b, then you square that. Okay, so it's the same here. Here we're going to say that we're going to factorize this. Okay, we're going to do it like that. And then we're going to say cos x, or not really factorize, but we're going to put the squares like that. After we do this same function can be sine x, like we've done here, over cos x. And then we can square both like that. But we remember that this one inside here is an identity that gives us what? Tangent, right? So it can be tan x squared. But remember, they've told us don't use the chain rule. Okay, so we're not going to use the chain rule because the chain rule will actually just differentiate that. Okay, and then it will differentiate the whole thing, meaning that we are still prevented from using it. So what other thing can we do here? We can say that this is going to be tan x. Okay, and then we're going to say tan x again. Now we found what? We found our product rule, something that's completely different from the chain rule. Okay, they can give you that limitation, but it's really not essential. But now we see that we can use the product rule here because those are next to each other. So what are we going to do? We are going to say that dy over dx. Now, since they are same, we're not going to write them down because we just need to remember. We said that this one has a relationship with sec, right? And then we said that it's squared sec. So we're going to keep one and then differentiate the other. So tan x, then we differentiate the other, okay? Then we can say plus again, keep one, okay? And then differentiate the other, right? So we can see that these are going to be similar. So they'll give us 2 tan x and then sec squared x. That is if you, well, this is a bit fictitious, but if they prevent you from using the chain rule, because if we had used the chain rule just here, we would have been able to find our solutions just from here. Okay, but then if they give you and they want you to apply a bit of trigonometry, they will ask for that limitation, but it's rare. And well, I just thought I could, have a spot through that. Right, all the best.